Okay. So first of all, thanks to all the sponsors and organizers. You're doing a great job, and thanks everybody attending. I know everybody's quite tired of all this online stuff, but yeah, let's just make it fun. So feel free to chime in and just type in into the chat window. Couple of words about me, probably um, nothing really new. So if you want to get in touch, those are the contacts, and that's it. Agenda for today. I'll just give a quick intro to machine learning. We'll discuss black versus glass box algorithms, what is actually interpretable, some AI and ethical point of view type of models, and then we'll go through a couple of those packages and then dive into the Azure automated machine learning. But first of all, in the beginning, the machines learned in darkness, and data scientists struggle in the void to explain them. So let there be light, or let there be rock and roll, as AC/DC said. So I hope the concept and the idea will shed some light onto that. So first of all, the overview of ML. You probably heard and seen this gazillion times, so I will definitely not lose any time here. What I want to share with you is just I will be focusing literally some section around here, which means that the rest will just be as it is. And this modeling part, which is also somehow connected to understanding, will be focus of this session. So it's really a small portion of this whole overview schema that we know what we call it machine learning. Okay, so the black versus glass box. So the black box, we've heard a couple of times, that the more complex the data science becomes, the more black box the models are, and this is basically the problem that everybody is facing, and this is also the reason why a lot of these packages, concepts, and formulas have been developed to basically just shed some light how to understand, how to interpret, and what to do with basically with the results, especially in these black box models. So what are the glass and what are the black or glass white? So the glass or the white models are usually easier to interpret. So we can say, linear regression, logistic regression, naive Bayes, K99, stuff like those, versus support vector machines, neural networks, and anything that comes basically quite complex assembled models. So why are these black models? Because there is a lot of computations that is not really intuitive or directly interpretable or understandable or seen by data scientists. So and these are basically the problems that a lot of data scientists are facing. So imagine your typical linear regression where you would have, let's say 2 or 3 variables, and you'd say if I add some age, I would get more, let's say, more income, which means that, if a person is older, there's highly likely that this person would get more income. And this is straightforward, straight and easier to understand. Whereas, the more you add some input variables, the complexity basically rises, and also accuracy, because we can explain much more, but this means that a lot of people then are struggling to understand what basically lies behind. And for instance, neural networks is something like that, especially with those hidden layers. The word hidden is somehow resonating, because it is something that only algorithm knows how to combine two, let's say, input variables or two features that are seemingly unconnectable, and the algorithm tries to connect and get some additional, let's say, variance or explanation out of those models. And the same goes with ensemble models. We'll see later that there is a lot of a lot of these new ensemble models that are basically just fraction of, or boosted versions of some previously known models that were easier to interpret and are now much harder to interpret. And also on this graph you can see, which are easier to interpret versus which are harder to interpret. So what is the interpretable machine learning? Usually we ask, why did my model predict this outcome? Or what is the evidence for this prediction? How sure I can be that this prediction is correct? Usually if I change one input, what's going to happen? Or how will my prediction change? And why, for instance, this model made this particular error? So these are all the questions that usually the data scientists are facing. And these are also the questions that, whenever you come to your, let's say, board or, your manager, and your manager asks, okay, so can you explain me this number? And you basically say, yeah, but this model is, 95% accurate, so we don't really need to understand it. But this understanding is easily and can be easily translated into business action. So that's why this interpretability of these models became much more incensed, because data scientists were struggling to, especially with the black box algorithms, to have some decent interpretation out of those models. So basically, how does this look? If there is a interface that basically gives you an explanation to this particular model, you can then understand why something has happened, or why this particular, let's say, feature did, succeed, adding some additional light on the model, etc., etc. So these are all the components actually that makes your model more explainable. What is explainable AI or machine learning is basically quite a new emerging branch, as I said, with some benefits, especially in the business, to basically improve the performance of the explanations, which can definitely make much better decision making, and it also gives not only data scientists but everybody involved in this machine learning process much more control, and with the control or the clarity comes also the safety, because you are more safe, or you understand it better, which means that all the other actions can be much more safe. You also trust in the model, meaning that your stakeholders will also take this into the account, meaning that if we create some decision, it is easier to interpret in the real life. Also ethical, and also the GDPR. So these are all the benefits that basically come to this explainable artificial intelligence or machine learning, and it's also available. And the same goes with Microsoft. Microsoft stands for transparency, fairness, inclusiveness, accountability, and also this privacy or security, which is basically just the same, but also Microsoft has adopted this concepts and started implementing them in the Azure Machine Learning, or the SDK, Python SDK, and stuff like that. So these are all the important aspects why we want to do this explanation. In other words, or in other hand, it is quite hard to explain. Why? I've been doing this for quite a long, and on my daily basis we are facing my business. We are facing these problems, how to explain a particular decision, or why did model predicted this way, and sometimes it's not really that straightforward or that easy. So it basically also takes a lot of time and efforts to bring a model to this level that can be explainable. There is also some other lack of that. I've put it tabular versus image versus text, which means that if you have your data set in a tabular mode, which means, your typical data set, it is, or it can be interpretable, versus image and text, those cannot or might have some difficulties. With text, that's possible. With image needs to be transformed into some other aspects, or let's say serialized in array of numbers, and then can be applied, or the concept can be, or the principle can be applied. But basically all three types of data types can have, or must have, will have basically the same packages used. Okay, before we dive in, I want to just give you the basic concept and idea of how this interpretation basically became actionable. There was basically a Microsoft guy. I'm just trying to find. Okay, so this is Mark Ribeiro, was actually the guy who wrote the first article, and this is the URL to this article. He basically created the LIME, or the concept behind the LIME, and explained the whole concept. So I can share the slides, but this is the link. I'm just going to copy paste the link into the chat window for those who are who would like to read this article. And he was basically saying that, and this was basically done for LIME, this local interpretation. The idea how to understand the model is by doing so-called local interpretations, which means that you take a fraction of your, or let's say subset of your data, and try to interpolate based on different features, and get some additional insights why this particular point was here, or why this, let's say, classification decided to do this grouping together. So this was actually something that he came up versus the global interpretation, which basically understands the model as it is, and does not go into this local approximation, how to, predict variable is behaving. So the idea is that starting from local interpretation, you can do this by approximating the behavior of complex predictive model, or you can use, as I said, some base estimators to understand the behavior of these single predictions. Versus the global interpretation, again, this one, where you would have, you would basically be interpreting the whole decision function the way through different dimensions of your data set. So basically, you will say, okay, this applies to my whole model, or this applies to my whole prediction. So these are those two concepts were derived basically from this idea, and this is how basically the whole concept of this interpretability became actionable. So trying to understand these small fractions, trying to understand these small fractions of sensitivity, basically, analysis. So this is again taken from LIME. LIME was probably the first package, and again, sorry for jumping up and down. I'm just trying to basically visualize here how the how this local versus global works. Is that basically if I take a lot of small predictions, and let's say this is my my model, my function, and these are my smaller local explainables, let's say extraction of different set of, or the formula extraction of different formulas, features, and you basically apply them on each variable on each data point and try to understand why this has happened. So this is basically the way Lime was actually created. So okay. Now switching back to Azure ML, the explainability part was introduced, as I said, maybe 2 years ago, a year ago, and it came based on 3 types, especially with tabular. It basically adopted the SHAP package and also Mimic, Lime as well. And then also it basically enabled text, again SHAP, or image, again SHAP, but there are different kernels or different type of functions that can be used to understand this type of models. So if you once you decide to install the Azure ML explainers, you will have those packages available. So SHAP is probably the most common now in Azure ML. And also you will get feature permutation, Mimic, and Han, as well as Lime, for those different type of explainables. Everything is incorporated. Once you go to the Azure, you will see that everything is basically incorporated as a GUI, and you can drill down, you can slice, you can make cohorts, understand particular cohort, why this particular subset has happened, etc., etc. So it's very, let's say, user-friendly. But again, since it's a open community project, there is an SDK available, and you can easily adopt this SDK or use any other function or any other package for creating these explainable models. Okay, as I said, what is supported is actually this Azure ML interpret, and if you go to the GitHub interpret community, you will find there is a whole set of those packages available for you to start basically digging in. And as I said, it's a open source project in Python that helps not only train but also explain these black box models. Since it's a SDK, you can also use it locally and change the compute, switch it to cloud, stuff like that. So it's pretty much straightforward. And you have also, scikit-learn, SHAP, Lime also available for if you want to play around and stuff like that, which are supported. Seen from this diagram, supported are SHAP tree explainer, deep explainer, linear explainer, kernel explainer. Again, depends on different type of data, if it's tabular, if it's image, or if it's text. And also you have this Mimic explainer and permutation feature importance explainer. All are available through the GUI, which means that once you either create this automated machine learning, you can then decide which run you want to go dive into and get started working on that. Okay, so what I want to do now is I want to go quickly through. Let's go first to Azure ML. What I'm gonna do is okay, I hope you can see my screen. So once you log in into the your Azure portal, you just go to Azure Machine Learning and you select your whatever you want to your environment. In this case, I've prepared AutoML Interpret, and you launch the studio. what you need to do is you just create all those assets beforehand, and then you can start working on. So, and this is brand new completely just for this session, so there is not really much runs available because I wanted it to be just straightforward and very clean. So what I did was, first of all, I've uploaded the dataset. So in this case, it's a Pokemon dataset for those who are Pokemon fans, and you can dive into exploring the dataset. If you want to consume it, you just easily copy paste this. You can see my subscription. That's beautiful. And basically copy paste it into your local onto your local notebook, Jupyter notebook, and start working on it. And you can also see what are the variables and what's available here. So I have the name of the Pokemon, and then a lot of these different features basically describing each of the Pokemon. So if there is any Pokemon fan, please go ahead and just raise your hand, give me a sign. So and what I will do is basically I will be predicting whether a particular Pokemon is legendary or not. So basically this is, you upload the dataset and you are already off to start working with that. The next thing you would need to do is you would need to create some compute power. So again, straightforward, very simple. I've just created a simple instance which has, couple of different flavors available. I'm just sticking to the Jupyter notebook, so it's much easier, and you can also do the cluster, the inference clusters and attach compute. So not really going into that because it's not really the focus. So I did ran this, and it ran for 1 hour, basically yesterday evening. Again, the complete data set is fairly I think it's around 800 rows, not really that big. And I said, okay, find me the best model. And for this best model, and you can see the best model is the voting ensemble, of course, with the accuracy and everything. And then I said, okay, but for this particular model, I want to have explanations now available. So in this case, you will see that nothing will be available for you until you decide, okay, now what I'm going to do is I'm going to go and start explaining those models. So what happens in the background is you will have another run created for each of this explanation, and also you will have some stuff going on with your compute power. So it might get resized. So, just be patient in terms of that. So, and you can see if you want to see the complete run, or you can go under the child run and see, what has happened in this particular child run for this particular explanation. Both are explanation and fairness, both are still in preview mode and has been, I don't know, for quite long. Fairness is again something that is available on GitHub as a repo for the Python. So if you go to probably fairness Python GitHub. Yeah, this is the package that is available. No. Anyways, there is a package especially that was basically adopted based on that. Not really if it's that. Probably this one, yeah. And it was adapted in this incorporated in this SDK. But explanation, as I said, is available in a couple of different flavors, as we've seen: Shep, Lime, and that's it. So those. Okay. So let's go back to my run. I ran it only once. You decide which model you want to investigate, or for the explanation part. And I did a couple of those explanations. So first of all, you would get the model performance. You would have the dataset explorer, and you would have aggregate feature importance and individual feature importance. So based on that, there is different package in the background. So let me just quickly jump into the notebook. I don't want to be too much confusing, but no, it's not here. It should be here. I just want to quickly give you the inside of that. So I'm just going to go to my notebooks. Sorry. And let's do the binary classification. I don't know what's happening. Okay, I'm just going to close. It's this one. Okay. So all these different tabs that you see are basically just combined from different Python packages that you can also use the notebook and create those things. So you can see the mimic explainer, and then you have the shape tabular explainer. So these are all those, the dataset explorer, the tabular explorer, and the mimic explorer. Again, really depends on what basically which model you've selected and what type of the explanation you're trying to do. So this again is something that comes out of the box, and then you can start exploring how you want to dissect your data, how you want to aggregate a particular point. You can edit the cohorts, as I said, create subset, or say, okay, I'm interested only in that subset, give me the explanation. So all those are available for your convenience to start exploring or understanding the complete explanation why this particular model has performed this way and was selected the best choice. So basically, very clicky, very user-friendly, and as I said, different aspects of those explainability comes and derives from different those explainers, whether it's Shep, Mimic, or PFI. So those are basically what comes out of the box. So going back to the slides, you can see that this basically resembles the what we've seen on the graphical user interface in the Azure. So again, the mimic explainer, PFI, permutation feature importance, and really depends on type of the model or the data set that you're using. It will take some bits and pieces from this Shep package. Okay, so but I wouldn't want to go any further until we just have a look into a couple of those packages that you can either download through Python, through R, or through any other machine learning product like SAS, NIME, maybe H2O, AWS, really depends the flavor you're using, but all of these are basically free, open, community driven, and a lot of companies have basically started to rewriting those and incorporating it into the products they offer. So basically Microsoft did the same. So what is LIME? LIME stands for Local Interpretable Model Agnostic Explanation. Again, remember the slide that I was explaining beforehand. So it goes locally. It's not really interested in the whole picture, how the model or how the function is basically moving, but it's saying, okay, I'm interested now in these bits and in this, etc., etc. So this is why it's local, and why it's interpretable, because since it's not as a complete but only subset of a prediction model, it's much easier to understand. What it does, it basically generates a fake data set, scores this new data set with the black box estimator, then train a new explainable estimator to mimic the prediction, and then tries to get the results out of this smaller subset. And the same logic is, as I said, available in LIME and also LE5. LE5 stands for explain it like I am 5 years old. So, and as I said, for those who are really interested in this, there is a link in the chat window, which basically explains how Mark Ribeiro, the guy's Microsoft employee, came up with the whole concept. So yeah, so how does LIME work? We've seen pseudo. Another one is, and very commonly used or very famous to say at least, is SHAP. SHAP stands for Shapley Additive Explanations, and is based on the game theory explaining the output of basically any machine learning model. What it does, it basically calculates the credit allocated with the local explanation, and basically that then tries to classify it and see what is the outcome, or basically tries to explain what would be the results of it. SHAP, in my personal opinion, is beautiful because of the visualizations, and that's why most likely also the Microsoft decided to use SHAP. To be honest, I never really compared the LIME versus SHAP, or let's say Skater or LE5, but yes, but I've seen that people were also doing that as well. So this is another one, and how does it look is really depends on the type of the problem you're solving or the type of the predict variable. It has extremely beautiful visualizations, so you can really dissect your prediction variable and deep dive into that variable or particular subset of that data set with this variable, and try to understand why the model predicted the way it predicted. So it can be time consuming, of course, but at the end it basically gives you very great insight of how the model basically behaved or predicted, and how the model will be behaving. Then there is another one, PDP, PDP plots. So what it does, it basically, with a simple idea, it plots one or two features against the target, and then or against the predicted values, and creates explanation why this predicted variable or value or those two features are basically intertwined or correlated, and why not. So it basically just builds a lot of those feature pairs one by one. PFI is even more logical, simple, and very intuitive. And it's what it does, it basically just takes each feature, permutate it, and see how the metrics changed. So it in fact is the concept is close to let's say hyper tuning or parameter sweeping. And that's why it's simple. So it basically is just creating a lot of, let's say, quote unquote simulations. I'm just going to take this feature and play with it and see how my metric is going to change. So, let's just say I have 100 euros on my bank account, and let's just see if I go to the groceries and take something for 5 euros, what's going to happen, or something for 50 euros, how's going to happen, etc., etc. So it basically fairly simple to understand, especially to interpret. Okay, so we've seen the Azure ML explainability. Again, all these are basically available online, so it's nothing really, all those packages are available online, so it's nothing really that special. The only thing you have to do is, set up the Azure Machine Learning Studio, and that's it. And I want to now jump into this Azure ML Interpret. So as I said, you have 4 aspects of those. 3 are the global explanations, and 1 is the local explanation. So the model performance, dataset explorer, and aggregate feature are the global explanations, meaning that they can basically explain the whole model as it is, and those individual predictions is basically what it does, that it takes subsets of, let's say, quote unquote fake data and just play with it, with this subset of features or data sets, and creates these local predictions, and then try to explain how the model is behaving. So again, jumping into the Azure ML, those 4 are basically the first 3 are global, and this one is literally the local explanation of the model. The whole thing, as I said, it takes some time to basically to train, and even if you have a lot of models, usually you would be interested in top 5, let's say, and you can then start working on that. Another thing, as I've already shown, is you can also use this as a notebook, and you can start, explaining anything basically. So again, this is taken from the Microsoft website. So I'm just explaining this for the sake of the usability, not really explaining the model. So what you can do is you just go to the notebook, and you can either create a notebook or upload the notebook, something that you've already written or something. So it doesn't really matter. But the beautiful part is each of those notebooks has also the CLI. So in this case, if you go to the Microsoft website, and if you want to follow this particular notebook, you would need to have Jupyter widgets installed. So this is fairly simple case, but if you don't have the right widgets installed, this will basically fail. So the beautiful part is that you can just click here, open terminal, and what it will do is you can copy paste. You can copy paste this command like this, and just wait until it's loaded. And once this is done, basically you can use this particular widget. So the same goes and the same applies for any other widget. So the beautiful part is that now you have also the terminal if you want to install some additional environment, whether it's Conda, whether it's some additional widgets, stuff like that. So the beautiful part. So again, as I said, this is something how you would go about. If you want to do, let's say, explain binary classification, and again, local, which means that I'm not basically doing the global interpretation, but I'm focusing on local. And you can import the tabular explainer, which is based on shape, or you can do the mimic explainer or the PFI explainer. So both those two are basically, all three are available in this library, which is again available if you take the correct environment. So if you take the Python 3, you will see that this will fail. If you take the Azure ML, this already comes pre-installed. So again, you can take any of those. Go and comment that out. Let's go with the PFI. So basically you just run this and then load the data, make the split, do the support vector machines, and then do the explanation part. Okay, I have to uncomment this and do the explaining for the and again, it runs beautifully. Get the global explain this. And I can skip that and I can print out the results. Again, you have the importance rank, and of course you can then either train, sorry, wrong. You can train locally. Okay, this one is, I can only now visualize it. Okay. And you can train it locally, you can train it globally, really depends on the functions that you are using or taking, and that's it. So and the beautiful part about this is also that this basically generates a URL, or it gives you a interface right here, which basically is, in this case, using the PFI. I can copy paste this, or just like open new tab. And what it will do is it will take this complete subset and basically give me this overview that we've seen is available in here. So now I can basically just play with the cohorts, explain or explore the data set, do any type of the feature importance, understand how this particular subset basically does, etc., etc. So really not going into too deep right now, but just to give you a glimpse what can be done and what is available for you, and also all the results or all the models can be exported, imported, and you can either use those locally or globally. And of course, as we've seen at the beginning, once you insert the data, you can basically get the, I'm just going to go back to the dataset. The outer ML basically creates a secure connection to your subset, and basically what you can do is you can copy paste this and go to your let's say local machine. So this is my local host, and I can start working on that as well. So basically what I would do here is I would just let's go here. I would add a command and I can run this. So now it will go, first of all, once I run this, I will need to set in the credentials, get the data set, and then start working on that. So again, beautiful. but I need to have also this Azure ML interpret installed on my, let's say in this case, my local machine or whatever, for whatever reason I'm going to be using this. So, and then again, I can just play with all these feature importance, or I can create explainers, and then based on those explainers I can start scoring the data, etc., etc. So I'm not going to run this because it's just too much code and might take too long. But again, I can also what I wanted to say was I can also take my model. So let's say I'm going to go into this run and I can download my model. Sorry, the voting example. I can also download the model in a pickle version, especially if the model is not that big. And I can then use this model. So now it's already downloaded because it's small, and I can use this model locally in my on my local host. So what I wanted to go through is on this data set, I wanted to also run, since it's the Pokemon, I wanted to show you what you can do also besides Azure ML. You can also use the scikit-learn. So the scikit-learn basically has some other capabilities as well. So you can start with the decision tree, get all the thresholds and stuff like that. And oops, some errors. And then you can go and create, let's say, a decision tree, which will basically give you explanation. Again, decision trees are very beautiful for explaining your models. And you can also do that for logistic regression, and also explain this in a logistic regression. And what I did was I also imported the shape, so the Shapley, and started seeing for these particular features which one is important and which one is not important. So again, many different classifiers can be used. So again, complete data set, just playing and goofing around with different estimators. So you can also draw the tree, which failed because probably was missing some Java, and again do the feature importance. And again, once you have everything, you can basically just start seeing which features are important. So this is something that was that is fairly new, but then again, not that new that it wouldn't have been possible with any other package. So again, it goes on and on. So that's basically what you can do with scikit-learn. So then there is the PDP. So what you can do is you basically import PDP box. So and oh, this is strange. Okay. And what you do is basically this will also give you the interpretation capabilities that are also available in Azure ML. But again, you can do this locally on your local host. Again, I'm also importing some Keras packages in order to get the results back. So again, writing some functions, and at the end you would get those. Remember, PDP were just basically two target features or target variable in one feature, different type of correlations, and you can see how those models are basically behaving and which one could be correct one or the best one. And then I also jumped into the Lime. Again, Lime is something that Microsoft gives you as a capability, and you can also use Lime, but in this case I've seen Lime, people use Lime more with let's say for some text or something, but in this case I did it also Pokemon dataset. And then there is also the Interpret community. So if you go to the website, the GitHub that I was explaining at the beginning, you can also get the sense of what they basically created in this case for these interpretations. And then there is also, if you're interested, there is also interpretable models, I think. This was taken from GitHub. A beautiful, probably notebook. I hope it's still available. From a guy who basically created a beautiful comparison of LE5, Skater, and SHAP in Python. And if you go down, you will see that it basically also gives you, explanation how to do the feature importance, partial dependencies, plots, again, PDP, PFI, all those that are also available in Azure ML can also be available here. So not really sure if I have the link to that. But anyways, this is basically what I had prepared for the session. Again, just dive into this Azure ML and basically start playing with this explainability if you are interested how the models are working and why the models are performing the way they are, etc., etc. So I think this is then my last slide. So thank you. We have 6 minutes, so if there are any questions, just go ahead.
Yes, I think Elisa had a question, but you already answered it.
Okay, so
no, there is another one from Elisa. Do you want me
go ahead.
to spell it? Yeah, it's what about explainability for time series, forecasting, and anomaly detection? Are these methods still valid?
Yeah, good question. I am struggling with time series, to be honest, because I am doing a lot of time series, and it is quite hard to interpret. To have this interpretability or explainability. What we are basically doing are we've somehow taken the shape local interpretation. So this segment, just a second. So this local interpretation, what we've did, so with different aspects to, map MI, I don't know, some deviations and stuff like that. We've basically created this local interpretation to do the explainability. But then the problem is, whether the time series is very sensitive, or if there are any outliers or any missing values. These are also very skewed in terms of the understanding why, how, for instance, let's say, I don't know, how the weather influences, how the sun influences the consumption of beer. So let's make it fairly simple. So yeah. So going back to your question, those are valid, but it really depends on type of the time series that you're using and the context that you're basically the business context that you're having in the back. So, but yeah, as I said at the beginning, exactly with the time series, I had some issues and struggling to deliver some valid interpretations in terms of business value. For the anomaly detection, there is also some out-of-the-box anomaly detection, but to be honest, once you go that deep, especially with the time series, I don't use it in Azure ML. I only use Azure ML to get the power of computations and then introduce my own Python code, and that's it. So notebooks, yeah, you can get the notebooks. So Francesco is asking, yes, you can get the notebooks. And so can you briefly explain the logic behind SHAP and why it is? Okay, so I think we've done that as well. What's the difference between the PFI and the Mimic? Yeah. Again, remember this slide. This slide really depends on the type of the data you're having and the type of the models you're using, and what is basically the PFI, how does it work, and how does the SHAP work. So yeah. Okay. Thank you.